Good evening, everyone. My name is Ugu, an admin at the NAIJA-JUG community. And on today's lightning session, we have Oluwatimilehin, who will be taking us on Apache Lucene. I don't know how to pronounce that well. Is it Lucene or Lucene?
Lucene.
You have always wondered what powers like search engines like Elasticsearch, or how you can integrate a very featured it starts featuring into your backend applications, then you really won't want to miss this session. Okay, before I hand over to our guest speaker, please react to your favorite emojis to hype him up. So we'll get started. Everyone, let's hype our speaker. All right, without wasting much of our time, Oluwatimi, the floor is yours.
Oh, thank you. Good evening. Thank you very much, everybody. Good evening, everyone. Give me a moment to share my video. Let's see how that works. Are we good? Okay. All right. So thank you very much once again, everybody, and thank you for the to the admin for this opportunity. And yeah, I'll be talking on Apache Lucene today, and it's let's call it a search, sort of a search library. It's used for searching, right? And I mean, for context, this is not going to be a lecture, sort of. It's not going to be a lecture, that's one. And secondly, I might be looking at my screen here. I have my notes written and also, pardon me. And so that being said, but before we get on with this, I want to sort of ask a quick question, and I would actually love it if it is interaction, not just show of hands or so. Like you can just unmute and talk, right? Because this topic is deep already. It's deep, to be honest, and it would be good if we associate and just participate. So who here has developed or used Elasticsearch or Jira search bar, or before, or even Android search or anything? Has anyone developed anything and used Elasticsearch? Okay. But then definitely you had used, so if not developed using Elasticsearch, I'm definitely sure you must have used Android search bar, maybe on your phone. You tried searching for something and other stuff, right? So basically, behind that whole stuff is Apache Lucene, even for Elasticsearch. So Elasticsearch itself was built on top of Apache Lucene, right? And it's added a lot of its own extra features, used for distribution and all these old things, REST APIs. That's what Elasticsearch brought on top of it. But the core of Elasticsearch itself is actually Apache Lucene. So it's not which one is better than the other, right? And before we actually continue, how this topic came on about, or this thing itself came on about, it's something we use at my place of work. And it's fascinating because when I got there and I heard, oh, we are going to improve the search engine, I'm like, great, Elasticsearch. And they're like, nah, we use Apache Lucene. I'm like, oh. And when the moment I heard Apache, I was like, this is core old stuff. I'm not going to be involved, right? But then it's been interesting. It's actually been interesting going on with it. So I started digging about this topic, and what I genuinely found, right, genuinely surprised me, and it's a rabbit hole. Everything is just a rabbit hole on its own. And so this session is not going to be like a lecture. It's not going to be like, oh, I'm lecturing you, pick your note and solve. It's going to be more of like an interaction. Let's keep it that way, right? Let's keep it that way. So first things first, let me share my screen. I'm going to share my screen. This window, entirety, share. And yeah, I've been always trying to avoid the statements, can you see my screen? I will just assume you're seeing my screen. I just want to assume you're seeing my screen. Right. Thank you. So, yeah, first things first, how Apache Lucene makes search work. How Apache Lucene makes search work. So, Oh, yeah, we've gone through this over this, and I was saying who has used Elasticsearch and all these things, Hibernate Search, Android Search, and all. They all use Apache Lucene behind the scene. Now, let's look at a problem. Let's look at why. I wouldn't particularly say this is why we have Apache Lucene in the world now, but then let's look at it this way. Why Apache Lucene? Why can't we just use SQL search, right? Why can't we just do it? So imagine you have this is a query. This is a query here. So imagine you have a database of books, right? Books, and you have title, author, description. Simple. Now, if you were to search for, you want to get books that have a description Java. Say you go to a website and you're like, oh, you're looking for books in Java. Then you search Java, typed as seen on the screen right here. Java, small letter, lowercase, all through. If you have in the collection or in the database, you have 10 billion books, why not? You can already imagine that your search query, this search query selects all from books where description is like this, like Java. You can already imagine that it's going to search all of those rows, every of those rows, right? And that's number one thing is that's slow. That is slow. It's going to just go all down, right? Secondly, it is dumb. Why do we say dumb? Right. So if you search for lowercase, we have lowercase Java here. If you search for capital letter, uppercase J, A, V, A, it could come back, unless you're trying to manually, do this in your code or change all these things to lowercase, change all this to lowercase. On its own, it is just dumb. It can't intelligently say, this person is searching for something like this, right? And thirdly, it is brittle. And what do we mean by brittle? Well, if you make a typo, which everyone is prone to, instead of J-A-V-A, you do J-A-A-V. You can already know that you are getting 0 returns. You can already know every book is going to tell you no result found or something like that, or null or so. And lastly, it is unranked. And what do we mean by unranked? Well, if you look at your database, you're just going to query the database, it's going to return everything that matches to you. It's not going to look at relevance. It's not going to look at the score of, do you need this document? Do you need this particular role? Is this necessary to your search? We'll get back to how that is important or why that is important, right? So that is one problem we have with the typical SQL search, right? And then comes in Lucene. What does Apache Lucene bring? Well, Apache Lucene is just like the direct opposite of all this. Like actually the direct opposite of all this. It is fast, very fast, very, very fast with the algorithm. This is going to be sort of very introductory. It's not going to be like going deep into things, but it is very fast. It is not dumb. So even if you have small letter, capital letter, whatever, it is going to still return something to you. It is forgiving when it comes to typo. Apache Lucene is forgiving when it comes to typo. It is not a replacement for SQL or something, please. It is just a search engine, right? So it is forgiven, and of course, it ranks stuffs. If you look at your Google search, for example, you search something on Google, and if it's returning, it's telling you, oh, there are 1 billion records of this thing. Have you ever wondered why? Let's remove, oh, is SEO. Have you ever actually wondered why some results come at the first page, and some, they just die at those pages you never even click page 2 or page 3 hard, right? Google is sort of ranking them like, okay, yeah, this ranks better, this makes more sense, this kind of, all this kind of stuff. So they have their own search engine, they have things that power it. Apache Lucene does something like that, so it sort of scores or look at the relevance of the results and brings things as close to that, right? So how does Apache Lucene even do this? How does it do this at all? How does it do this whole quick search, whatever thing? Now we're going to go into something. If you've ever read a book that had, I don't know, index. If you ever read a book that had index, we don't know how many of us had actually read or seen something. Yeah, this is better. I don't know how many of us have actually seen these and thought of the usefulness in our years of reading. I don't know. I barely, when I'm reading the Bible, sometimes, just go to search for some particular words. You go to the back. That's if your book even has it. Not every book has it, but this is called index, right? You will get to why this is better. Why this is important. Apache Lucene uses something. We say this is the single most important idea in all of search, the inverted index. The inverted index. See it this way. When you go to the library, which is very much complicated at this point, but I'm going to, let's take it, let's simplify it, because you can have catalogs and all these other things. When you go to a library, you meet the librarian and you ask, I'm looking for books on humanity. He or she, they don't go through the old libraries, the old books in the library to help you scan through which has history of something that returns it to you. That is exactly how, if you run something on SQL, like select all or something, that's exactly how it should do. Is to go through every row. Okay, which one of them has the description, which one of them has this and all this stuff. But a librarian would not go through every book in the library looking for the context of something that has something on humanity and then come back and return the old books to you. They show you a catalog. They say, go there. When you go to that catalog and you say, okay, I'm looking for books on this. What they particularly do is they do their search, this quoted search, they do their search and return you the book. But you don't expect that they might have read their old book in the library for them to return those particular books given to you. So Apache Lucene, bringing Apache Lucene in, how it does this thing is the inverted index. What does inverted index mean? If I were to give you a book, or give you 10 books, for example, you have 10 books, and I'm like, please, can you give me books that have the word catastrophe in it? Well, if you're SQL, you would open the books and read every line one by one, looking for, if the books have 1,000 pages each, you will go through all those and I will wait. And you return the books to me. That's not efficient. That's not even nice, right? But then, if you were to do inverted index, you sort of go to the back of the book, like something like this pages, you see abbreviation, you see date, time, you see all these things, you see comparative, for example, and it tells you which particular page contains this word. But for Apache Lucene in this term, it gives you the book that contains it. So instead of searching for the books that contain the word you gave, you requested for, like searching for the book one by one, it just gives you the word. You give it the word, and it just gives you the book straight up. And you're like, how does it do that? How is that work? Well, it's sort of like, instead of scanning the document, Lucene sort of does a lookup of the word and gives you the book that has the word. So that means it must have done something behind the scene, taken the words, stored them, indexed them some way, and attach them to the, index a word, attach it to the book, index a word, attach it to the book, and they're like, oh, I need this word, I need this book that has the word this, and it just goes straight to that word, and the word points to the books that contain it. So for this, if you look at this, not to make you confused, if you look at this slide here, a normal index will give you, you're asking for the words that contain Java, is to check through book 1 and read the whole thing. Oh, this one contains Java. Check through book 2, checks through book 3, contains Java, But inverted index looks at the word and looks for the books that contain that word. So in this case, we have Java and we have book 1 and 3 straight up. It just returns it to you. So that is the idea of inverted index. Inverted index. Is there any confusion? Does anyone have any question at this point? It is still theoretical, but does anyone have any question at this point? I guess not. All right, guess we can move on. Oh, someone has a question. All right, everybody, please go ahead.
Sorry, I wanted to ask, why do they use that word inverted? I understand the point of an index, so it doesn't have to scan everything, but why inverted? What makes it inverted?
All right, so what makes it, good question. What makes it inverted basically is just looking at the screen here. It's just like, instead of doing A to B, you're doing B to A. Yeah, you just invert it, basically. Instead of looking at the books to search for the word, like you look through the, or let's put it with English, instead of looking through the book to find the word Java, it just looks at the word to find the books that contain it. Do you get it? So it's inverted, right? So it's
inverted. Like it's inverting the way you usually search for things.
Exactly, which makes perfect sense. So now, how does it do this? Well, we go to the next slide. It says it does what we call analyzer, basically. Analyzer. It goes through this. This is where the intelligence live. Analyzer. So how does it work? It's like a pipeline, and you can of course add your own. You can add more things. You can add. You can add your own custom analyzers. But then that is if you go to the. I think I should drop the link to the documentation, which is actually a great thing if you have time to read it. It's very amazing. I assure you, it is very amazing. This is documentation. You can try, you have patience, it is very good, concise. No, not really, it's Java, but it's good. So going through this, we have the analysis pipeline. So what happens? I search, I give it a let's even run away from the word search for now. Let's go away from the word search, because now we're trying to look at how does it even index distance? How does it know what is what? How does it know which word and which document and all this sort of stuff? All right, so you have a book. There's this raw text here. Let's assume it's a book or it's a .txt file, and it has the word the quick brown foxes. Makes sense. Now, when this goes through Apache Lucene's analyzer, which is an abstract class, I think, yes. Yeah, it tokenizes it. That's the first thing it does. So, like, the quick brown foxes makes sense. Put in an array, something like that. Tokenizers just use the word tokenize. Then change everything to lowercase. Right? Like I said, this is configurable, but this is a simple thing. It's very configurable. You can say, you know what, don't change. For example, maybe you want some keywords, some maybe an ID of someone, or some trying to look for a perfect example, maybe ID card of student. Maybe the words are always capitalized, and that's how it is. That's what they search by and all. It soon makes sense for you to then change this to lowercase. Be adding this over edge. You can say, you know what, just leave it. But that's another thing. That's keep going deep. I told you that when we started this whole thing, it's a rabbit hole. It's a huge thing. It's interesting actually. But then let's keep it simple. So it brings this lowercase filter. Everything's on lowercase. It removes the stop filter. What are stop filters? Words like words like common words, they, in, over. Like I wouldn't go to a search box, maybe on Jumia or whatever I'm searching, and look for the word on, kind of. Of course, you can still configure things, but it does remove it. That's where like I say, that's where the intelligence lives. Then you're left with quick brown foxes. Even at this, it still does something. The stem filter. What does the stem filter mean? It leaves quick as it is. It leaves brown as it is. Then fox. It was foxes we came up with, but now we have the word fox. Okay, so when I'm searching for foxes, what happens? Well, it should give you this. It will still return this to you. So it stems it. And why is it? What's the purpose of that? I think I was using it at a point in time. It stemmed the word. I'm still trying to search for that. I'm going to do that after now. It stemmed the word pragmatic to practice. I don't know if that was a bug. I don't know how they relate, but it actually stemmed that word. So when I was looking for the word pragmatic, something practice came out. But then that aside, so you can have a word, something like coming, C-O-M-I-N-G. It will stem into come. So anytime you're searching for the word come, it will bring you, or even if you search for the word coming, it will still bring you the recommendation of, hey, there's a book that has the word come. You might be relevant for you. That's where relevance, you see, we talked about relevance when we started. That's where things like relevance start coming into place, right? And so that is that. So in all of these things, what do we need? What if we're going to do all these things ourselves? I mean, we say Apache, as I said, Apache it has a very good, API. You can just plug in things and all, very small thing. At the same time, it is large. It is a rabbit hole, huge one, right? So, but then to do things, you only need quite a few number of things, and they have these things you see on the screen. The first one is a document. A document is like a row, like a DB. When I said you have a database of books, you have title, maybe a row, the data in your database has the title, the author, maybe the number of pages, then maybe the ISBN number, then description, where you can search, hey, I'm looking for books that talks on Java or JavaFX. It looks at the description, right? So a document is like a row in the indexing world of Lucene. Then a field is a piece of data in that document. Think about it. E-commerce. We are building an e-commerce application. We have products. One product has name, SKU number, price, a description. It has slash price. It has actual price. It has a whole lot of information. It probably even has the maker. Probably even has the expiry date. But ideally, none of us here could confirm. I could ascertain that. None of us had gone to these popular sites and look for a product that is expiring, and you're searching for a product and saying, hey, filter by product that are not expiring tomorrow. So ideally, you would not need the expiring date to search for the product, right? You just search for the product. So that means in the all of the attributes of a particular product, you necessarily don't need to store in your database. Yeah, store everything. That's nice. But for your search engine, you wouldn't need to store how when it's going to expire, how the maker stressed to create it, all this kind of stuff. So basically, a field is a named piece of data in a doc, that is the document. So this document that is above contains field. So for our e-commerce case, you can say we need a title, we need a description, we need the actual price and the slash. Yeah, maybe we're just searching, right? So probably title and description, right? Then in the filter engine, you can be filtering by the expense or whatever. But for searching, you might just need the title and description. How many of us even know the SKU numbers of the products we buy? We don't really care, right? So that's if you can say, okay, for every document, just store in that document the title and the description. That's all. Then you need an index writer. An index writer does it writes the documentation, the documents, that is this is our record, the first thing, into the index. It writes into the index. So it does this thing. Basically starts by doing this thing we went through. It takes the title. The title is the quick brown fox, or the description. You start tokenizing. So next thing, you're searching for products that has brown, or like a brown. Maybe you didn't really say brown bag. Maybe you wrote brown and you click search. Well, you're expecting the quick brown fox. I mean, yeah, you get it. So that's what this does. The index writer start writing the index, right? And when it does that, that's done. That you are done about indexing, basically. It indexes all those keywords for search later. This is where search comes in. Index reader, index searcher. Index reader basically opens down your index, what we saved. We've indexed a whole lot of books, 10 billion books. Apache Lucene had indexed them, saved them for future search. But you just don't, the searcher does not just search like that. It has to go through this index reader. Index reader opens the index for reading, and then index searcher can run the queries. Like, hey, I'm looking for books on Python. Then returns the results. And of course, the results will be probably the book or the product, that kind of thing. And one important thing is when you're storing your words, when you're putting in words, you have text field. We are going to look at code to look at all these things. We have text field and we have string field. Well, for text field, they get analyzed. And when I mean they get analyzed, we go back to the structure. They go through the raw text, tokenize them, lowercase filter, store filter, stem filter, they get analyzed. which makes sense. So you can use that for titles, descriptions, body text. But for string field, for example, you don't want them to be analyzed. You want it to be as it is. For example, in the ID, some ID are not necessarily always UUID. It could be a combination of text and string, numbers, let's put it that way. Letters and alphabets and numbers, let's put it that way. So you have ABC 1, 2, 3. And the ABC, you want it to be as it is. You don't want it is capital letter, it is capital letter, right? So you want to store it as it is. So that kind of thing, it will be stored as a string field. And that's where it does not get tokenized, it does not get lowercase, it is exact value as preserved, and it's good for exact match. So when a student is searching for their ID, they can just capitalize this and this and that. That's probably some part of the search engine or something. I mean, depending on your usage or use case, status codes also, you might want to leave it as it is. Don't tokenize it, right? So when you're tokenizing things, you have to be careful. I mean, when you're analyzing things, you have to be careful. Am I using text? Should I use text field or string field for this particular thing, right? And then lastly, before we go into the demo, we have the query toolkit. The query toolkit, like just from the word query, it means searching, basically. It means searching. Now, in your searching, Apache Lucene is powerful. It does not just just the way it stores this thing is the way it comes out or things like that. Or if I store it this way, that's how I must just find it or something. It's not stagnant. It's not how do I put it? It could be dynamic. Things you could run wild with it. For example, let's check temp query. The temp query here searches for exact temp match in a field. The exact temp match in a field. So when you're searching for something like where a title and the title should be Java, it returns things like Java for you, which makes sense. That's what we would expect. You wouldn't want to search for Java and start seeing books on Python. Something is broken in that search engine. Then phrase query, this one you're searching for the exact phrase. So when you say I'm searching for a title of the book called clean code, it returns clean code for you. As a phrase. Those two things. Then we have Boolean query, which you can use and or not. You can have a title that is Java and description that is this concurrency or so. It brings up something like that. We have fuzzy query. Fuzzy query is interesting. When I told you that SQL is not forgiven. It's not forgiven. You want to search for Java, you wrote JAAV, you're not going to get a result. But for fuzzy query, this is where it comes in. You're like, I get it. You're trying to search for Java, but you wrote JAAV. So, but then I assume, so I'll just give you books that have the word Java in it. Then you come like, nice. You might not even look at what you typed, what you wrote in the search query, because like, well, that's what I wanted, right? So you look at it like, this search engine is smart. Well, fuzzy query to the rescue. So you can mix a text. For example, here we have development. I don't know if you can see. Yeah, we have development, right? But we missed the E part. But then it will still bring out development for you. Then we have query parser. Well, this is just your normal email readable string. There's nothing much to it, right? So now we're going to go to the demo. If we have a question, we're going to go to demo. And if you have any question, please you can state. I know it's vague for now, but I guess with this we should be able to do something. If you have any question, you can raise it now before we go to the demo. And I put this in a GitHub. All right, a moment, I'm posting this. Yeah, the GitHub link to this. All right, you can ask a question.
Okay, good evening.
Good
Yeah,
evening.
can you hear me?
Yes.
Yeah, thank you for, I think I'm catching it. I'm catching one or two on this is it Apache Lucene?
Listen.
I am finding it out. Okay, thank you very much.
Yeah.
So I have a question, and that's been but because this particular technology now, I don't know, it seems new. I don't know, is it new, and why is it not like rampantly used, why is it not, would I say, popularly used in probably even the e-commerce that you spoke about, and I'm not sure if I've heard of some let's say financials using that particular this particular application, or is it adapted for? Probably, I would say what is adapted for is this when you are doing this AI integration, Spring AI, probably use it to fetch what. And even when we're doing something on that, I think they still didn't use it. So is it like a forgotten, useless technology? I'm just saying because I don't see this. It's integration.
That is very valid, and that's why I spoke. I think I talked about it when we started the slides. I just searched also the usage. So it is not even new. It is not new. In fact, it is the old of oldies, right? But the interesting thing is, it's quite amazing how you go into some code base and you just find things. And this code base, it's not due to the fact that they were built in the 90s. As a matter of fact, they were built in the 20s, like recently. And the choice of using that, I got to a code base, like I said, I use it at my place of work. And the first thing I said, I asked my team, like, sorry, has anybody heard of Elasticsearch? And like, yeah, Elasticsearch, yeah. And I'm like, so what's this? Like, what are we doing? And they're like, okay, we're going to search on Apache Lucene. Then I started and I'm like, Apache Lucene is the core engine behind Elasticsearch that is used in every product. I mean, almost every e-commerce right now. Yeah, it's an old stuff, but it's still being worked on, it's still being maintained. And it is very this particular question. I want to put a challenge to you. Let's assume you are building. Yeah, great. Finally, great. You are building an app, a phone application. You want your phone application to work offline without internet. Like without internet. What your phone application does is for students. Students, they put all the documents there it gets just the document on the phone. Maybe they update content. It gets updated. But offline, they can search for documents that contain particular words or search for whatever has this particular whatever. At that point, right, we start thinking of what should I do? Should we use SQL? Should we use whatever? One of the fastest and best thing you can ever use is Apache Lucene. What's Elasticsearch? Yeah, you can use Elasticsearch. What it has brought to it is just it brought on top of it. What is built on top of it is RESTful API. Distributed system. So that means, as you have e-commerce, you can have different servers, different products, and different whatever. Elasticsearch will still touch on all of them, right? But Apache Lucene, boy, behind the scene, all these things are listed here. Your Android search, Confluence, Jira search, Hibernate search, Apache Soul, which is also another search stuff, Elasticsearch, they're all built on top of it, right? And I found it like an interesting thing to just talk about because we could just talk on Elasticsearch, right? Everybody could search that on YouTube and all, but I wanted to check the technology behind it. All right, next question, please.
Okay, thank you for the answer. I don't know if, okay. Yeah, thank you for the answer. So, my last question, sorry, my last question. So, though I've not really used Elasticsearch. I mean, but I think I've not really used Elasticsearch. But now the Apache itself, like, what's the cost? Like, what's the cost of using it? First of all, if Elasticsearch is just like now you're using Spring Boot, Spring Boot. You don't do Spring Free. You don't really go low to just using like plain Spring. Plain Spring you get. So because of the Spring Boot bootstrap many things for Spring and all this configuration you get. So now what's the cost of like using the Apache Lucene itself? Because I know like in terms of space, it's not like it's when it's searching, it's not going to your database because it has to have its own space, just like Elasticsearch. So like what's the cost of actually implementing it in your code base? I believe it's
all right.
It should cost both your like and the complexity and also let's say your system capacity also.
Yeah, that makes perfect sense. That makes perfect sense. So the cost of it, I would even almost start from even just using it in the code base. It is the cost of adding it to your code base as even as a library is very minimal. It's more of this will look like I'm making this thing out, but it's more of like you're even using something internal when you use Apache Lucene in your code base. And when you're using so like Elasticsearch, you're bringing in some external stuff and all. That's the first one. Secondly, the way it indexes things, the way it indexes its words and tokens and all this old stuff, it's actually very minimal, and it is, what did I say, very preferred when you're doing such, like the kind of thing I talked about now, building a mobile app that you can do something offline, you don't need to go a lot of things, and it's very fast, it's very quick and fast. It's actually very perfect for that, for things like that. And the cost in itself, say, it's compared to, that's one of the things, compared to Elasticsearch, is actually very minimal, the cost of it. Yeah, Elasticsearch gives a lot of other things that you can use, right? But this one, because it's fast and it's simple, like very simple, it makes the cost of it very, very minimal compared to any other thing, of which those ones are built on top of it. And like I will raise this, I will let this person talk about. Looking at this, the companies and organizations that are using it, actually, like I said, till you get to some places, you feel like you find out what do they really like, why are they using this and that? Saying this, you're like, oh, so these people use this. They use stuff like this, and all these log analysis, these companies use these and all these things, Wikipedia and all, and be like, so it is very relevant, right? And it's not a popular thing you will see on YouTube. In fact, when you go on YouTube, before you find relevant videos, that's why I just talk with the documentation and this book, Lucene in Action. All right, so the next question, please. Someone?
Good evening.
Yeah,
It's me again now.
Oh, right.
Actually, Mr. Sam puts the core of my question. Because okay, but like he didn't ask like something specific on this here. Is this Lucene fine for like monolithic applications? Like all these companies you called now, like they are mainly like microservices and stuff. Like even in Elasticsearch, it's also microservices. So like for those of us that are just building like monolithic stuff, like would you recommend using like Lucene since you said it's lightweight?
To be honest, that is exactly one thing it's good for. When you have a monolithic stuff, you're not having distributed servers or anything. All this is expensive. It's like over engineering, even using sort of over engineering using. Using Elasticsearch on a single server or something like that, monolithic stuff, right? And that is what Apache Elasticsearch brought on top of it, distributed system. This is very easy and very simple to use, as you will see in the code base. Even though that, of course, I am my co-founder in this world, Claude, brought this code together, under my immense guidance. I lectured it what to do and what
Ojoro.
So we are going to look at the code base. We are going to first of all look at the functional, like what does this thing do? So basically, this is a book search application. Let me run and don't see. I just love I love command line things, right? I really love command line, to be honest. And I love saying things in my command line, not just writes one line and returns one line. You see all these things. Of course, this is the work of my co-founder. Yeah, and like I already put the link on GitHub. You can explore. It's very simple, very, very simple. So this is what it does. It takes books. Then I just find text from that book or from those books. And we have using books. You can think of log analysis. You can think of a whole lot of things actually. So it's not just about book or e-commerce or something, But for this case, this application, this stuff has books added already. Not you will see the books, but it's not like books. But let's calm down. So it takes books. You search for give me a book that contains this particular word, and that's it, and returns it to you. So let's search for Java or claim. Let me search claim. No results for claim, right? Now let me search Java. It's searching for the description of the books. Like here, you can see that there is Clean Code by Robert Martin, and in the description, you have a handbook of agile software craftsmanship for Java developers. In this description here, you have Java applications, and this one you have best for Java programming. Let us try using the same search, and instead of writing Java, I'll write Jav, Jaav. No result. And you'll be like, but you said Lucene is smart. He's smart. You're defending a dull guy. He has just 2 brain cells, blah, blah. All right. Like I said, that is a feature. That's an API. Instead of using that search, let's use fuzzy. I mean, this is just keyword, doesn't matter. Fuzzy Java. It still brings what? Java for me. It's like, I see, and it's using this algorithm, right? It tolerates typos. This search, when we did search, is like, hey, I don't tolerate typos. I don't tolerate it. But fuzzy search, which is this thing, which is part of their API, like you can see here, fuzzy query here tolerates mistakes, right? So I can say fuzzy develop and miss just MNT. It still brings your journey to mastery in software development and coding, right? And we have other search, we have other things, you know, like that. Let's go to the code basically. So you get the idea, you just search for books and return something for you. So how do we add this book? Listen, Apache Lucene does not sit on your, it's not your substitutes for database or something. No. It sits on your application code basically. How you take, say let's say we're uploading PDFs. Let's say this application takes PDFs. So you upload PDFs and then you search for the PDF that contains a particular word. That's where Apache Lucene comes in. But the uploading of the PDF and the taking the words, reading the words is not its business, honestly speaking. How you save it in your database is not its business, particularly, right? So you take your PDF, you write your application code, your business logic to extract, you find other libraries, it takes the word, extracts the word from that page or from that document, then you can give it to Apache Lucene. Then now we tokenize all of it. It gets those words, remove remember our analysis part here. It does its thing, it removes, it tokenizes it, lowercase filter, stop filter, removes all this D on your over else minus stuff, and then stems, stem them also. Maybe you have something like communication. Maybe it can go to commune. I don't know. Please, commune can mean going from one place to another, and it's also mean like commune, talking with someone. So that's English for you. But then it could stem it. So next time you search for communication, it still gives you commune. It still, it still gives you that commune thing, right? And why it does that, we'll still discuss. That's very simple. All right. Okay. Please go ahead.
No, sorry, go on. I just go on.
All right, great. So indexer, two things. You get your text, Apache Lucene indexes it. Then searcher, so you'll be able to search for it back. Just two things, index and search. Please tell me it's a mistake again. Tell me it's a mistake again. No, it's not. Please answer. Ask a question.
Oh, sorry. Yeah. So I'm sorry for drawing you back. There's a clarity I need. I don't know. Clarity I need from when you made the statement, when you were explaining how Apache Lucene does not really care about the database. Is it that it does not care? Is it that it still goes, like when it's searching for things? You said it uses, so it's use the word and go to the index. So does it search the database, or it has its own, like Elasticsearch takes memory from your the main system, not the database itself? Does it have its own, like it manages its own memory instead of like going to your database, so it doesn't have business with your database that way? I don't know if that's what you mean.
Yeah, so great question. It doesn't concern itself with it depends on where you build it depends on your application. When we talked about if in fact now it doesn't it doesn't concern itself with your DB basically. Why? Because it already takes its own text. Hey, I need this text, I index it. I need this text, I index it. It exposes that index basically, and that's why this slide I was saying these are just a few things needed. It exposes that index. Search, when you are trying to search in your application on the front end of your client, is searching that index via the index reader reads it, then it exposes, index searcher searches what you're looking for. Now, why it does not concern itself like, how you store your stuff? Yes, you can, we say we are storing books, right? So yeah, your application can still go ahead and store your stuff in Progress or Postgres or MongoDB or whatever you're storing it. But part of your application logic, because you want quick search, right, is that during the process of probably searching and uploading the documents, after you've uploaded maybe a batch job or something, or however you're doing it, batch processing job, you can allow Lucene to index that, to get that document, analyze it, analyze the text, stores the stuff. It stores its own index that it exposes to your client, to your client, right? And so your client, what does it do? You basically type a search, whatever. That search index searcher goes through index reader to check the index and return something to you. That thing it returns to you, if you click, oh yeah, enter, that one can then go to your DB, like, oh, fetch me this document. It basically returns you the document that contains those texts. It's just the name of the document that contains those texts. Like, hey, I know this document. Yeah, it contains this text. That's all. It doesn't care if your DB should fall today. It will still do its own thing. And now, why it does that? There are two. This thing it can store stuff in memory, like in memory in RAM, and that's what I did here exactly in this line. You just store stuff in memory, or you can actually store it in a document in a persistent form in a folder, basically in a file actually. So you store stuff in a file, and it's very minimal, very, 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 very minimal. Right. So is that clear? So it's up to your own due diligence to say, hey, they've removed the products from the database. Let me remove that thing from the index also. It's just so people don't keep searching for broomstick. Like, there's broomstick available, and your database is saying no, not found. That kind of thing. So yeah, due diligence there. Now for the quick, so because of time, we have to run quick for this on this basically. So we have just three. If you go to the link. We have three files. We have three files. The first one is your main file, of course, and this is all design. All this things you're seeing is just design, right? It's just designed for now. Let's go to the indexer, basically. Now, what does the indexer do? Basically, we are building index. This is the method we are using to build our index. This first method, we just have two methods here. Two methods, apart from the constructor, of course. Two methods. And like I said, analyzer. An analyzer can be, that's just basic thing here. This thing here, analyzing. This was it. That's what it does. So yeah, this is an analyzer, an index, right? All from Apache Lucene's library. Then, of course, the constructor. Now build index. What does build index do? This one is just printing something. Now we are indexing. That's what Samuel was asking, like, that's something related to, not particularly what we were asking. We are using RAM here. That's what we are storing our stuff, not a DB or persisted stuff. Now you can either store in RAM or in a folder, basically. So it creates a folder and it has its own stuff, basically, but it's very minimal. When I mean minimal, I mean minimal, basically. So great. Index writer, sorry, a moment. This is disturbing. Great. So index writer, we are storing our index in RAM on my computer's memory. Fine. Now we are saying these 5 books, like we said, index writer, just create a new writer, right? Fine. These 5 books, add 5 books basically. It has an ID, fine, a title, fine, an author, a description. We're just adding 5 books basically to the index, right? Good, that's all. And that's we are basically done. And we close it. We close the writer. That is all. That is basically all. So let's say you have your application code that is checking through a PDF. It will just give it these fields. Everything we're looking at here, add book, writer, number, this is a field, ID is a field, title is a field, author is a field, description is a field. That's what we talked about field here. I'm talking about field, that's important thing. So each book is a document, and the fields, the title, the whatever, they are in the document. And you have an index writer. All right, you have an index writer, fine. And add book, we are basically calling add book. It creates a document. So this add book here is a method. The add book here is a method that's adding every book. You basically create a document, Apache Lucene thing, new document. Then you add a field. You know, we talked about string field and text field. If you can recall, we talked about string field. We said text field will be analyzed. They will go through this whole process, right? While string field will be stored as exactly. Now let's see things in action. So we open a new document, then we add a new string field, which is stored as it is. And that's the ID. We need the ID to be as it is. Don't tokenize it. Just leave, don't do anything to it. Just leave it as it is. But for the rest, the text field, where you can tokenize it, the field, the author, the whatever you will do on it. So that means it will take introduction to algorithms as it is like this. Introduction to algorithm. In fact, let's do introduction to algorithms. Let's go to our file. It comes here. It takes introduction to algorithm, tokenizes it. We have introduction to algorithm. Lowercase, of course. Stop filter. We have introduction to algorithm. It removes the two. So we have introduction algorithm. Stem filter, introduction algorithm. Well, I guess those are the stem. If anybody is against that, you can raise your question, but I guess those are it, right? Then it indexes it. That's all. That is what the indexer is doing. That's what the indexer is doing, basically. Now we go to the searcher. So you're done indexing your stuff. Very quick, very nice. Now, whatever you index, you use to analyze your tokens, whatever you use here, basically, the analysis pipeline. If you say, hey, analyze it by this thing, don't do lowercase filter. It just makes sense that at the same time, when you are querying, that is you're searching, it should still maintain that, hey, remember, we said, don't use lowercase. What do I mean? If you go to a library and you give someone a code, you tell someone, hey, help me store this document. And the person says, oh, this thing is critical, it's complex. And I'm like, okay, let's use this algorithm to store it. And you leave. If that person, that librarian should go to the toilet, for example, and another librarian replaces them, like for the meantime. If you come back and say, give me the book I gave you, and they're like, I don't think we have this, or if we have it, I think it's complex. If they think that they can do it and they go to the bookstore or whatever, or the shelves, they will come back with nothing because they didn't know of the algorithm or the key or whatever that he used to store. I mean, the other librarian used to store this, and that just makes sense, right? So when that one comes back, they will come back and say, no. And you're like, yeah, no, I stored a book here. I was here 5 minutes ago. Look at your CCTV, blah, 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 blah. And that one comes out and like, what's happening? I need my book. Yeah, I gave it to you. Oh, that book we use this code for to store. Yeah, exactly. Fine, I'll give it to you. It just, I'll be like, I didn't know about that. It just makes sense that the way you store it is like sort of the way you query it. So if you store something and you're like, I'm trying to look for a good example. I think that's just perfect enough. If you store something in a way, it just means that you find it in a way, right? In that way, part of that way goes through that pipeline of looking for it. So that's why we have analyzer here again. The same analyzer we use that index. That's what we're using here, right? And an index searcher. Fine. And what does this one do? Okay, what does this one do basically? You know, I was showing you search, fuzzy search, and all this other stuff. This is search. If you just want to search, this is search. You are using query parser. This is query parser here. If you recall, we have query parser here. And we're like, hey, the way I asked you is the way you should give me. That's just simple. But this is fuzzy query. Fuzzy query here says, I'm typo tolerant. You know, I can forgive you for mixing some words. I will return the closest words to them. And that's what fuzzy does here. This is fuzzy. This is just fuzzy. It's just like, you can make a mistake. I will pardon you, right? This is phrase searcher also. You know, there are different kinds of the way you want your things to happen. And that's just all these other things are okay. Printing results, list all, and all this other stuff. Then the book demo, basically, when you run the command line, if the first word, the command is search, you use the normal search. If it's fuzzy, you use the fuzzy. If it's phrase, you use the phrase. This code is I've posted the link. You can check GitHub and explore it and fork it and try anything you want to do with it. It's actually very good. But that is actually all. That is simply all. And this is powerful already. That is just it. And it is very, very powerful already. Very simple, right? So just once again, here, when you build it, how you build it, the index, right? You just build it in RAM, store it in my RAM, don't save it in any whatever. Use the normal standard analyzer, which is this. You can go to, I sent the documentation to, links to the documentation, you can check it. This is just a normal standard analyzer. Just use the normal standard analyzer. Yeah, then index whatever, just index those stuff. You know, add new documents. Instantiate the index writer, add new documents, add each document. I need ID field, title field, description field. Then that's all. You close it, you're done. And when you're searching, you just open the index reader and index searcher. Like I said, index reader and index searcher here. I said, we are rounding up. I said index reader opens the index for reading so that your index searcher can run queries on it. Right. So you need, when you're searching, you need the index reader and the index searcher basically. Right. So index reader, index searcher. Your regular query, regular search, you just run search for Java. It returns Java for you. Search for development. You can see the development here does not have E. It is still return development for you. Right. And that is all. That's basically about it. That's basically. Now about scoring, we'll run through this. About scoring and relevance. I'm like, okay, so what's scoring, what's relevance, what's this, what's that? Apparently, because Lucene tries to look at things like, hey, what is scoring basically? How relevant is this? How relevant is this to your search, right? It does something called scoring. And so when Lucene finds, it uses an algorithm basically. It uses another, it's called BM25. Yeah, BM25. But then it is in itself, it is based on something called TF. Sorry, I'm trying to remember it. It's called TF-IDF. TF is temp frequency. How frequent, when you tell me look for Java, how do I bring up a relevant book to you? There are 100 books here, but I'm giving you 10 that are very relevant. Why? And it's saying, because Java is coming out in those words more, that kind of thing. There are a lot of books, all of them have Java in them, but this particular 10 all of them have at least one Java, text word in them. But this particular 10 books have 50 Java words, so they are probably more relevant to what you're looking for. That's text frequency. Then the IDF is inverse document frequency. What does that mean? Oh, okay, so we have 100 books. You're looking for, you've come to Java library. Welcome to Java library. We have 100 books. You said, I'm looking for Python. A book that contains Python. Oh, nice. Apache Lucene goes through the books in the index, says, you know what? I'm returning this particular book over this book for you. I have 5 books to give you, but I'm ranking this one number 1, this one number 2. Why? All the books here, none of them contain Java, Python. But because these few books, this number 1 contains 2. So in the rarest case, in the first one is, hey, all the old books have Java, but these ones have more Java contained in them. So that's term frequency, how frequent the term is. While the IDF, inverted document frequency, is like inverse document frequency, is like these books, it's very rare to find Python in these books, but these particular ones even have Python. That's why I'm returning them to you. I'm making them relevant. So you see, it is just smart, basically. So that is the BM25 algorithm. That's how, it scores things and shows how relevant it is to you. So it doesn't just, normal SQL will just dump everything to you. But Apache Lucene we look at things like, so this is not a comparison, please. This is not a comparison. Like, hey, should I use SQL or Apache Lucene? No, please. Why I'm saying that is because in the first slide or so, we talked about the flaws of using SQL or so, right? So that's why I'm using that. So that's why we do scoring and relevance, right, in searching. Now, we've answered these. Apache Lucene is used a lot. In a lot of places, you'll be like, oh, really? It's really, really used in a lot of places below the scene, right? And like, see, Elasticsearch, you use Lucene, REST API, then distributed shards built for scale, basically, right? And yeah. Now, in this, we talked, someone asked a question that, okay, why should I use the monolithic stuff? And that's a book, right? He asked something in that length, right? Well, recently, and that's what, in my place, for example, this is what we're driving into. We are like, okay, so we want to move into Apache Lucene doing things on vector search. So it's not just bringing things by semantic, full text search or something. What of the semantic, thing, not just the keyword, what of the meaning of words? So if I search for land, can Apache Lucene bring property for me? If I search for mortgage, can it bring something relating to land for me? Even when the word is not mortgage. Things like that. So as we're talking about meaning, semantic meaning, not just keyword. What we've been doing is money is keyword. Java, it brings Java. What if I say Java and it brings something like programming? That is semantic, right? And that is, so this is a classic. On this side, you say classic search. You query for dog, it finds dog. It misses things like canine, puppy, hound, right? Because it's using term frequency and IGF scoring. Now, for vector search, right, it's a modern thing now. That's Apache Lucene 9 supports KNN. When you search for dogs, it converts it to a vector embedding, and it can bring similar things. Just in that document, it's bringing something like canine, something that has canine, or puppy, or loyal pet. So it's a very powerful thing. It's not magic. It is magic, though. It's very interesting, right? And so, as we round up, 3 things to remember. Just to review quick things to remember. The inverted index is the idea. For the normal classic Apache stuff. You ask for something, it does not just give you, it does not search through every book line by line. It uses the word that you ask for to search for the book, instead of using the book to search for the word. Using the book to search for those that missed it when that joint links, I will show an example of an index here. This is an example of an index, right? And if you open a book, the back page of a book, you find things like this. They're like, that means if you're looking for bracketed ellipses, go and check page 200. You see, if this was not there, you probably check through every page. And imagine if the book is just exactly 200 pages. So you search from 1, 2, 3, 4. I'm sure you stop by 10. That's if you're even diligent, right? But then the index here is helping you to like, hey, just search for, I'm looking for bracketed ellipses. Or just go to 200. Very fast, very quick. That's what this does for you, basically. And if analysis is where intelligence lives. The gap between finding exact word and actual useful search is in your analyzer pipeline. This other analysis pipeline we add there, that is where the intelligence is. The way you configure it is the way you want. You and Mr. Samuel and Ebube can have the same product, but they are search engine, they are using Lucene. But the way you search on one and what returns can be different from the other because of how they just changed their analyzer to be, in that kind of thing, right? And yeah, that's all. You are definitely have been using this. You probably don't know. You are probably using it already, but then, yeah, that's it. So as we come to the end, these are resources. You can check I sent the link to the official documentation. They have a GitHub, I think it's open source. You can check this book. I've been reading it too, Lucene in Action. And for, vector searches and all this stuff, you can check Apache Lucene 9+, version 9+. And this is supposed to be a punchline, but sorry. The search bar is a promise. Lucene is how you keep it. Thank you. Any questions? Any questions? Let's come to the end of this.
All right. So if someone has any questions, I'm ready.
I think a lot of questions have been asked. Yeah.
So that was a very lovely session. Personally, I know that me and Mr. Samuel learned a lot. I'm very eager to go and try out this Apache Lucene. Because most of the time, like when I build when I make applications, I actually rely mostly on SQL, like on Postgres.
Yeah.
On Postgres, like it has very useful search features that you can get away with using.
Yeah.
Well, and I think the downside is that's like full database scan that you just have to do because you can't create an index of a search keyword.
Yeah.
So, okay, we already passed our time. So thank you so much. Let's clap for our speaker big. That was not easy. Like
nice.
you learned something, even though you're not just dull, like you change him.
Thank you.
Okay, thank you everyone for coming to today's lightning session. Remember to follow us on all our social media handles on LinkedIn, Twitter, and If you missed any part of the session, this will be uploaded to YouTube. So if you're not already subscribed to our channel, please remember to do so. So thank you once again, Oluwatimilehin. Thank you
Thank you
to
very
all of
much.
us. Thank you to all the NAIJA-JUG community admins who made this possible. And we look
Mhm.
forward to seeing you in our next DSC session. All right. Thank you, everyone.
Yeah, thank you very much, everyone.